When DIRECTV first launched in 1994, there were two different ODUs. There was an 18-inch reflector with a standard single-output LNB that would provide service to one receiver, and there was an 18-inch reflector with a deluxe dual-output LNB that would operate two, and when connected to a multi-switch could provide signal to multiple receivers. Most installers scratched their heads and wondered why DIRECTV couldn't run everything down one cable like cable TV. Well, the technology just wasn't available. Fast forward to today, where we've gone from one single orbital slot at 101 degrees to 5 primary orbital locations with at least 2 polarities on each, stacked frequencies from 250 megahertz all the way to 2150 megahertz, and 2 different downlink frequencies. Things have gotten even more complicated. Now look at what we've added. Today we've structured our system to provide over 150 high-definition national channels and over 1,500 local channels, in addition to our already superior programming packages that include over 265 channels plus over 65 satellite radio channels. Well, our engineers have been working overtime, and in this session we'll be looking at the new delivery system that delivers it all on one cable, with the revolutionary new single-wire multi-switch LNB, or what we call the SWM. Hi, I'm Ray Edwards with DIRECTV's training department. In this session, we're going to be looking at the single-wire multi-switch LNB, or what we call the SWM LNB. You're going to love it, so let's get started. This is the SWM LNB. The very first thing you'll notice is a single output port. That's right, there's only one. Unlike the original single output LNB that can only provide service to one receiver, the SWM LNB allows you to connect up to 8 receivers off that one output. Not all receivers will work with the SWM LNB, but here's the ones that will. The HR20, HR21, H20, H21, R16, and the R22, or any models newer than these, have or will have tuners compatible with this LNB. Keep in mind a DVR with 2 tuners requires 2 separate frequencies. The total number of tuners you can place on the network is 8. So if you have 4 DVRs, you can't add any additional receivers. Let's look at the advantages to using the SWM LNB and a few precautions. The first advantage most of you will see is the ability to connect 2 tuners on a DVR using only one cable from the ODU. Because each tuner in the HR20, HR21, R16, or the R22 is capable of having its own assigned SWM delivery frequency, you can feed both tuners off a single cable. Another advantage is you may be able to use existing cables pre-run in a home and not have to run new ones. Though we would always like to see only approved RG6 cable with solid copper center conductor, there are times when you just can't get a cable from the ODU to the receiver. If the existing coax cable is in good shape, nothing is in line, and the run isn't too long, there's a good chance you can use it. Before you do, you need to run a couple of precautionary tests to make sure it's good. Here's how. First, read the resistance of a terminator and make sure it's about 75 ohms of resistance. Put the terminator on one end of the cable. Go to the other end and check the resistance there. If it's approximately the same as you read on the terminator, the cable is probably okay. At least you'll know it isn't cut or shorted and there aren't any inline components. Next, remove the terminator you just placed on the cable. Now go back to your test location and make sure you now have an open circuit. This will confirm the cable you have is the right one and that there are no components in that line. Another advantage is you can use a loop system to deliver signal throughout the home. A loop system is where splitters or taps are used to feed a series of sets off one drop the same way cable TV distributes signal. The SWM LNB uses frequencies between 970 MHz to approximately 1870 MHz to deliver signals. It uses a 2.3 MHz control frequency to select the correct satellite feed. Every component in line needs to be rated from 2 MHz through 2150 MHz, so it can pass the 2.3 MHz control frequency up to the LNB and the 970 to 1870 MHz downstream frequencies to the receivers. That means you have to replace every component in line with one that will deliver those signals. That includes the connectors. Remember, crimped connectors cause problems at higher frequencies. Use only DIRECTV approved compression connectors on all installations. Another advantage in using the swmlnb is that you have only one cable from the ODU to the house. That means you have only one cable to ground. It also means you'll spend less time routing or attaching cables and cutting on connectors. Let's take a look at how the swmlnb technology works. Here's how the single-wire multi-switch, or swmlnb, works. Each receiver is assigned a specific block of frequency spectrum directly from the LNB. The receiver and LNB communicate using a very low frequency of 2.3 megahertz. That low frequency signal from the receiver selects the proper satellite and polarity for the program requested on that receiver. A designated 100 megahertz frequency block transports signal from the LNB to the receiver in a range between about 970 megahertz and 1870 megahertz. The entire block of frequencies that contain the specific digital information for the channel selected is then sent down the cable at the designated frequency range assigned that receiver. Since each receiver in the system has its own unique block of frequencies, they are all stacked in a row on one single cable and routed to all receivers. The tuner in each receiver is set to receive all its programming information from one specific block of frequency spectrum. Since each receiver has its own specific block of spectrum, no signals above or below that signal range are used. Because the tuner is only looking at the predetermined frequency range, the other frequencies don't interfere. It's by assigning a specific block of the frequency spectrum to each receiver that we are able to stack all those blocks sequentially on one cable and feed them through the entire residence. I'm sure you all know what a B-band converter on every KAKU installation does. It converts the lower 250 megahertz to 750 megahertz Ka signals up to 1650 megahertz to 2150 megahertz. With the SWIM technology, we need to transport signals in that range directly to the receiver. The B-band converter is not required on any receiver receiving SWIM signals. Don't put a B-band converter on a swmlnb powered receiver. Let's look at the hardware you'll need when installing a swmlnb system. Since the swmlnb is unique to DIRECTV, it's essential that you use the right hardware. You can easily spot the SWIM KAKU LNB by looking at the output ports. It only has one. When using a SWIM LNB, every component has to be compatible. Splitters and other inline devices designed for and used in cable TV distribution networks just won't work. And because we're using different frequencies, every unused port must be terminated. Use standard 75 ohm terminators like this. Let's start by looking at the power inserter that powers a SWIM LNB. First, you need to remember that there are two single-wire multi-switch devices. There's the SWM, which is a standalone multi-switch that gets signal from a traditional KAKU 4-output LNB and has one single-wire output and ports for traditional L-band distribution for legacy equipment. Then there's the SWM LNB we're covering in this session. The SWIM standalone unit requires a 29-volt DC power inserter, and the SWIM LNB requires a 21-volt DC power inserter because these units can't be powered by the receiver. Make sure you have the proper power inserter for the SWIM LNB. Also, never connect a power inserter in a way that it can feed voltage to a receiver. This voltage will damage the tuner in the receiver. Another piece of hardware you'll need is the SWIM splitter. These come in a 2-port, 4-port, or an 8-port model. You'll notice the frequency range on all SWIM-compatible equipment is listed at 2 to 2150 megahertz. In order to align and peak the ODU, you'll also need an alignment signal locator, or ASL. The ASL is connected to the SWIM LNB and allows you to look at the signals from the satellites at 101 and 119 degrees independently. Speaking of alignment, let's look at how that's done with a SWIM LNB. One unique feature of the SWIM LNB is the way you read the signal level while aligning the ODU. Though the aligning and peaking is done exactly the same way with any KAKU ODU, you need to connect your signal level meter and keep the LNB powered. That's done using the ASL or by the use of a power passing splitter on some signal level meters. We'll look at the ASL first. The ASL looks like a four-way splitter, but it's very different. The input port at the top is connected directly to the swmlnb. The bottom left port is 18 volts out. The next port is power in. This is where the power supply cable is connected. You'll see the power ports all have red inserts in the connectors. The next port is labeled 119 and passes the signal from the satellite at the 119 orbital slot. The right bottom port is labeled 101 and it passes the signal from the satellite at 101 degrees. Here's how it works. Connect the input from the swmlnb. Now connect the power from the power inserter. The power inserter has to be in line because the output voltage of your signal level meter isn't enough to power the LNB. Your meter has an 18 volt output and the LNB requires a minimum of 21 volts. Don't connect any receivers to the ODU until you've peaked it. Once the receiver is connected, the LNB is switched out of the setup mode and you can't peak the ODU. Let's look at the ODU alignment using the bird dog signal meter first. Connect the 101 port to the meter input. Press the arrow button to select DIRECTV SWM 101. Now roughly align the ODU for maximum gain. Once you have the highest signal level, connect the jumper to the 119 port on the ASL and set your meter to read the 119 satellite. Now align the tilt. At this point you have rough aligned the ODU. Move the jumper back to the 101 port on the ASL. Now you need to fine-tune it using the dithering process covered in the KAKU ODU certification course. Follow the same dithering steps you would on any KAKU ODU installation. Now let's look at the alignment using the AccuTrack Pro. Follow the same instructions for connecting the ASL to the power inserter and ODU. Connect the 101 port to the meter at the 101 input. Turn the meter on and view the 101 satellite signal and rough align the ODU to get maximum gain. Once you have the highest signal level, connect the jumper to the 119 port on the ASL and set your meter to read the 119 satellite. Now align the tilt. At this point you've rough aligned the ODU. Move the jumper back to the 101 port on the ASL. Now you need to fine-tune it using the dithering process covered in the KAKU ODU certification course. Follow the same dithering steps you would on any KAKU ODU installation. Now let's look at alignment using a Digisat 3. Follow the same instructions for connecting the ASL to the power inserter and ODU. Connect the 101 port to the meter at the input. Turn the meter on and view the 101 satellite signal and rough align the ODU to get maximum gain. Once you have the highest signal level, connect the jumper to the 119 port on the ASL and set your meter to read the 119 satellite. Now align the tilt. At this point you've rough aligned the ODU. Move the jumper back to the 101 port on the ASL. Now you need to fine-tune it using the dithering process covered in the KAKU ODU certification course. Now let's look at alignment using the Super Buddy. Follow the same instructions for connecting the ASL to the power inserter and ODU. Connect the 101 port to the meter at the input. Turn the meter on and view the 101 satellite signal and rough align the ODU to get maximum gain. Once you have the highest signal level, connect the jumper to the 119 port on the ASL and set your meter to read the 119 satellite. Now align the tilt. At this point you've rough aligned the ODU. Move the jumper back to the 101 port on the ASL. Now you need to fine-tune it using the dithering process covered in the KAKU ODU certification course. With the ODU aligned, you can complete the wiring and grounding of the system. We'll look at that next. Like all DIRECTV installations, the system must be grounded to meet National Electric Code standards at minimum. Since there's only one cable from the ODU to the network in the home, you can use a single ground block. Remember, the ODU and the cable both need to be grounded. Always ground every installation to meet code in your area. If you aren't sure how to ground, ask your supervisor. In order to make sure everything is working properly on each SWM installation, you'll need a SWM installation meter like this. The SWM meter verifies that each cable drop within the home can support the SWM's operation. When the power on button is depressed for 2 seconds, all LEDs will turn on. If all the LEDs don't turn on, the meter's not functioning properly and won't provide an accurate reading. Connect an IRD to an electrical power outlet. When using the SWM installation meter, don't unplug the SWM power inserter from the LNB anytime beyond this point. Power on the receiver. Now force a software download by pressing 0, 2, 4, 6, and 8 on the remote control at the Hello screen. Complete the guided setup in the Automated Program Guide or APG download. Verify that you see video after the APG download. If you don't, check the cable run to the receiver. It may have an unwanted or substandard component in it, or you may have to repair or replace the cable and the connectors in that run. Now check each cable using the meter. Yeah. If everything is okay, all lights will be on. You can refer to the SWM meter troubleshooting chart you'll receive at the end of this session for the test results on each cable run. It'll let you know if the signals you need are getting to the receiver, and if they aren't, what the problem might be. Now that you've made sure all the cable runs are working properly, you can start connecting the other receivers. We'll look at that next. One of the great features of the SWM technology is the ability to connect a 2-tuner DVR with one cable. If you look at the input on a DVR, you'll see one is labeled SWM or, in the older models, FTM. By connecting to that input, you don't need to connect to the second tuner, but the DVR with 2 tuners still counts as 2 separate receivers. Remember, you can only operate 8 tuners off the SWM LNB, and each DVR counts as 2. Follow the same process as you connect each receiver. Connect the satellite input, connect all video and audio outputs, connect the phone jack, plug in the unit and power it up after it's connected to the LNB. At the blue Hello screen, force a software download by pressing 0, 2, 4, 6, and 8 on the remote control, and the receiver will update to the most current software. At this point, the LNB and receiver communicate, and the receiver is assigned a frequency block. If it's a DVR, it's assigned 2 blocks. Don't plug the unit into power until all connections are made. When the receiver boots up, it will see the SWM LNB and configure for the SWM system. If you power it up before connected, it may not detect the SWM and come up in a standard mode. If this happens, you'll have to shut it down and reboot it with a SWM LNB connected, and that's just unnecessary steps. So as you've seen, the new SWM LNB can certainly save you time and allow you to complete installs you might not have been able to do in the past. And the best part is you can do it all using only one cable. But there are some restrictions you need to be aware of. I'm sure over the next few months our engineers will start reducing or even eliminating those altogether. If you have an installation that involves a SWM LNB and you haven't been trained and certified in KAKU alignment, see your supervisor and get that certification. It's our goal to help you do your job better, faster, and with fewer hassles. From all of us at DIRECTV Home Services Training, have a safe and productive day.